Welcome to this video where we're going to be looking at evaluating powers with integer bases. So we just finished looking at powers. And remember that it's a way to write repeated multiplication. And a power has two parts. It has your base part, the bottom, and it has the exponent part, the little number at the top that tells you how many times you're multiplying your base. So in this lesson we're going to look at powers when our bases are integers. So when our bases are integer numbers. So to see what's going on before we look at it a bit more, let's look at a simple example. So here we have powers where our base is -2. So each time our base is an integer, in this case -2. So just like we would with normal powers, let's start by writing it out in expanded form. So -2 to the exponent 1 is just 1 -2. -2 to the exponent 2 is -2 times -2. -2 to the exponent 3, and I am just going to stop writing our times symbol. Remember, if we write it beside each other in brackets, it means multiplication. So -2 to the exponent 3 means -2 times -2 times -2. And similarly, -2 to the exponent 4 would be 4 -2's. And I'm going to leave this one for now. So let's look at evaluating them. -2 to the exponent 1 is already done. It's going to be -2. Now, -2 to the exponent 2 is -2 times -2. Well, the number doesn't change. 2 times 2 is still 4. But the question is, will it be positive or will it be negative? And if you remember integers, when we multiply two negatives, it becomes a positive. So remember our double negative. So you're not cool really means that you are cool. Right? So same thing here. These two double negatives become a positive. So this would be positive 4. Now -2 times -2 times -2. Well, remember, -2 times -2, we already said up here is positive 4. So this would become 4 times -2. Well, 4 times 2 is 8, and a positive times a negative, remember, is still a negative. It only becomes a positive if it's double negative. So here, it becomes -8. So we had -2, positive 4, and -8. Now let's look at -2 to the exponent 4. Remember, these three we just said was -8. So this is really -8 times another -2. Well, 8 times 2 is 16, and this time again we have a -8 from here times -2, so two negatives become a positive, so this would be positive 16. So you can kind of start to see a pattern, can't you? The numbers don't change, right? 2 to the exponent 1 was 2, 2 to the exponent 2 was 4, 2 to the exponent 3 was 8, 2 to the exponent 4 was 16. That doesn't change. What changes is just the sign in front of it. And most of you can see a pattern that it just switches from negative, positive, negative, positive. So -2 to the exponent 5, remember we're doubling each time, so 16 times 2, we know, without even writing it out, is going to be 32. Now the question is, will it be positive or negative? Well, if we look at our pattern, negative, positive, negative, positive. So this one will be negative. And the rule is, for exponents, is if it's an even exponent, like 2 or 4, our answer will remain positive. Whereas if it's an odd exponent, like 1, 3, or 5, our answer is negative if it's an integer base. And you can kind of see that because if you have an even number of negatives, they'll all cancel each other out and it'll become positive. Whereas if you have an odd number of negatives, it will still remain negative. And that's really our rule for powers with integer bases. The number stays the same, and we look at the exponent. If it's odd, it's negative. If it's even, it will be positive. Okay, let's try some examples now. So we have 4 powers on the board that we want to evaluate, find out what their answer is. Let's look over here first. We have -4 to the exponent 2. So here we have an integer base. So this means -4 times -4. Well, 4 times 4 is still 16, and a negative times a negative is positive, so it's positive 16. Another way of thinking about it is the exponent, 2 is an even number, so we know that our answer is going to be positive. So we know it's going to be positive 16. Whereas this one, we have negative 2 to the exponent 5, which means we have 5 negative 2's multiplied together. Alright, so let's ignore the negative sign to start with and just focus on the numbers. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now we look at the exponent. 5 is an odd number, so we know that it's going to be a negative answer. Another way you can think about it is these two negatives cancel out, these two negatives cancel out, and so this negative is left. Alright, because every two negatives becomes a positive. So every even number of negatives cancels out and becomes a positive number. And we're just left with this little odd one that makes our answer negative. Now over here we have negative 2 to the exponent 4. That means negative 2 times negative 2 times negative 2 times negative 2. And again, we just ignore the negative signs. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we know our answer is going to be 16. But this time, our exponent is an even number, so we know it's going to be positive 16 and not negative. Now this last one is a bit tricky. You may be saying, well, this is just the same as that question. Well, there's one little difference. In here, the negative is inside the brackets. So the exponent goes to the negative as well. Well, for this one, our negative's outside our bracket, so the exponent isn't affecting our negative sign. So we're going to leave our negative sign there, and it just becomes 2 times 2 times 2 times 2. So for this one, 2 times 2 times 2 times 2, same as there as 16. But not each of them have a negative. You notice here, each of the 2 we multiplied was a negative 2. Here they're just positive 2's with the negative out front, so our answer for this one is negative 16. Okay, hope you've had a chance to try these on your own and practice them. Let's take them up. Question number 1. Will negative 6 to the exponent 1023 be positive or negative? Well, remember, if we have a negative base, we know it will be positive or negative by looking at our exponent. Whether it's odd, then it will be negative, or even will be positive. Here, 1023 is odd, therefore, we know, since there's an odd number of negatives, it'll make a negative number. Therefore, it will be negative. Okay. Now let's look at these. We want to evaluate them. Now, negative 1 to the exponent 121. Okay, 121 is a big exponent, but let's think for a second. What number are we multiplying? We're multiplying 1. So 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1. Okay. So the answer is going to be 1. Because 1 to the exponent anything will be 1. Now we just need to worry about the sign. Now it's negative to an odd exponent. So just like here, it's an odd exponent. So our answer will be negative. Let's look at B. So negative 3 times negative 3 times negative 3. Okay? So first, 3 times 3 is 9. So this is 9 times negative 3, which will be negative 27. So we knew it was going to be a negative answer because it had an odd exponent. So it's negative 27. Now here we have the same question. Negative 4 squared and negative 4 squared. Well, it looks the same, but remember they're slightly different, because here the negative is inside the bracket. So for this one, this means to keep the negative and do 4 squared. Well, 4 squared is 16, so this one will be negative 16. Whereas this one means negative 4 times negative 4, whereas 4 times 4 is still 16. A negative times a negative is a positive, so it will be positive 16. Because here the negative is being squared, here it wasn't because it's not in the brackets.